For our next example, we've got the same thing. We've got two equations. What I'm looking for is the point of intersection, where these two lines cross at. Look at each equation separately. Let's take the top equation, minus 2x equals 6. In order to be able to graph, let's solve for y. Put it in mx plus b. Put it in slope-intercept form. Need to get rid of the 2x. Add it on over. Leaving me 3y equals. I can't combine them. It's not going to be 8x. I'm going to put 2x plus 6. Now again, I'm trying to set up my mx plus b. Now, divide by 3. You're going to notice this is going to be the same routine as add the x term, divide by the coefficient. You're going to see this quite a bit, especially in some of the earlier problems. 2x over 3. I'm going to go ahead and put that as 2/3 x. Remember, the last thing I want to do is turn that into a decimal. 2/3 is good because that's my rise over my run. That's my slope. Plus 6 divided by 3, 2. Well, that's great. That's my starting point. When I come over here to graph this thing, what's going to be nice is I start at 2. Where that's a fraction, last thing I want to do is 0.666666 repeating. That's not going to help. Rise 2 is nice. Run 3 is just as nice. There's my next point. Rise 2, run 3. Chances are one of those points, even if I want to go back 3 down 2, chances are the more of those points I put, the more likely it is that one of those is my answer. Now, unrelated, look back to your other equation. Let's graph it. I need to solve for y. Minus 8x to each side. As bad as I want to combine those, I can't. Negative 12y equals, I'm going to put it as negative 8x minus 24. Divide by negative 12, meaning divide everything by negative 12, just like we did last time. And again, you'll see the same routine over and over again, meaning y equals negative divided by negative is a positive. Reduce, divide by 4, the greatest common factor. And it would be the same if you want to divide by 2 and get 4 over 6. Divide by 2 again. But either way, you're going to get broken down to 2/3 x. Negative 24 divided by negative 12 is a positive 2. Well, let's go to graph it in mx plus b. I start at b. Well, that's interesting. It's the same y-intercept. Well, now my slope, my rise over my run, is the same also. What happens is one graph is sitting on top of the other. What we call this in math, the two lines coincide, almost like a coincidence or two things that happen at the same time. Well, these are two lines that happen at the same time. And when we look, it's actually because their equations are exactly identical. Back here, not only did they have the same slope, but they even had the same y-intercept. Well, that's what makes lines coincide, is everything is the same. Go back to our parallel. They had the same slope, but they had to have different y-intercept. And it's the different y-intercept that caused one line to be above the other and one line to be below. Coinciding is the other example. For this one, where do they cross? Here, 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 between those two. This has infinite solutions. And here's what's going to happen. In our homework, for every single problem, we're going to have 3 selections. A box where you put an answer. If we have an answer, make sure you answer as an XY ordered pair with the parentheses. I know a lot of times we've had separate answers with commas. This one is essential that we have those parentheses because it is that ordered pair 1, 2 where they cross. Another option is no solution. The way we know they're no solution is if they have the same slope and a different y-intercept. That's what makes them parallel. We look for the point of intersection. No solution means they don't cross. They were parallel. The next one, it's going to look weird. What they say is a weird squiggly, x comma y, a bar, and what they're going to have are your two equations. 3y minus 2x equals 6, or negative 12y plus 8x equals negative 24, and then that weird squiggly. Here's what this means is the set of all ordered pairs such that it works in this equation or it works in this equation. Because what we're looking for is what works in both equations. Remember how 1, 2 worked in both equations? Well, what happens is any ordered pair that works in one equation works in the other. Any ordered pair that works in the bottom one, works in the top one. That's a fancy way of saying any ordered pair that works in one, works in both. So all ordered pairs that work in one, work in the other. That's a fancy way of saying infinite solution. The way we know it's going to be this is if the two lines coincide. If everything, the slope and the y-intercept, are the same.